Keep this one and go. Okay, you guys all ready to go? Feeling pretty good now? Is everybody set up? Yes? No? Okay. Well, while you guys are getting set up, we're going to do a little bit of review. All right. So the first box is just going to be review of everything that we have sort of talked about so far. Okay. Taking a look at review. What do we call that shape? That shape that you see right there. What's it called? That red shape right there. Yeah, the shape is called a what? Parabola. You got it. So, okay, the actual shape that this thing makes is called the parabola. So the shape is a parabola. Where does a parabola, where does it come from? What's the name that it comes from? Anybody know? A quadratic. Yes. So, and what does a quadratic look like? I'll give you two options, right? Which one is a quadratic? If I gave you ax plus b, or if I gave you ax squared plus bx plus c. Which one of those is quadratic? The first one or the second one? The second one. Are we sure it's the second one? The first one. Are we sure it's the first one? No, we're not sure. Okay. We're not sure which one makes it. So what's the difference between these two equations here? The exponents, right? What's the exponent on this x right here? That's a 1. What's the exponent on this x right here? A 2. That's the big difference, right? So one of these is a line, and one of these is a quadratic. So which one do you think is the line? The first one. Yeah, this is a line because it has a degree of what? What's the degree in this particular case? It's a 1. The degree is 1. This is a quadratic. That's what we call these things. And how do we know it's a quadratic? Because of the degree of what? A degree of 2. Very good. So we have a quadratic has to be some kind of polynomial with a degree of 2. You guys, so far so good. Otherwise, we're going to call it a line if the degree is 1. And quadratics make the shapes that are called parabolas. You guys with me so far? Is this all review? Hello? Yeah, okay, good. What do we call this point right down here? What's that called? That's called the vertex. Yes, very good. The vertex. It can either be the highest point, or in this case, it's the lowest point. Yes, all right? Kind of a loaded question. It can either be one of those two things. It can either be the highest point, or it could be the lowest point. And today we're going to focus on how we find those things. And the other thing that you guys told me that there was an axis of symmetry. And what we do with the axis of symmetry is we draw a little dashed line here. And I call this axis of symmetry. Sometimes you'll see me put A period, O period, S period. And that stands for the axis of symmetry. And where does the axis of symmetry always go through? Where does it go through on the parabola? Not the origin, because the origin is this thing here, isn't it? The origin is at the center of x and y. But the vertex is not necessarily always at the origin. But there is something that the axis of symmetry always goes through. What is it? The vertex. Yeah, very good. So maybe we should write that down. Axis of symmetry always goes through the vertex. Axis of symmetry always goes through the vertex. All right, you guys feeling so far so good? Okay, good. All right, so the directions are going to be find the vertex, and all we're going to give you is a quadratic. And how do I know that that is a quadratic right there? How do I know? What tells me it's a quadratic? What's that? The degree of 2. Very good. So this whole thing is called a quadratic. Again, we know that. Yeah, see. Okay, and what we're going to do is find the vertex. All right, how do we find the vertex? Well, it turns out there's this awesome, sweet little trick that we're allowed to do in order to find the vertex. But you have to be good at identifying the A, B, and C. So a vertex is a point, right? Just like it is right here. This vertex is a point. Can you guys tell me what point that is? What point would that be? Is it 0, -2, or is it -2, 0? What point would that be? Yeah, this is the point 0, comma, -2. Do you guys agree with that? Okay, so a vertex is just a point, right? And a point always has two things. What are the two things that a point always has? It has an x and a y. Very good. It has an x and it has a y. So a vertex always has two parts to it, and it's an x and a y. So a vertex is always going to be an x and a y. All right? The cool thing is that we can easily get the x by just evaluating -b over 2a. This is the coolest thing ever. So the negative b, what am I talking about? I'm talking about this particular b, and I'm talking about this particular a. The x-coordinate will always just be negative b over 2a. That's pretty sweet. But the question remains then, okay, well, if that's the x, then how do we get the y-coordinate? And for that, we're going to plug in. So I'm going to show you how to do this stuff in just 1 second. All right? So remember, the vertex is going to be a point. It's going to be an x and a y. To get the x, all we got to do is evaluate negative b over 2a. And then to get the y, we're going to plug in. So that's going to be our game plan. You guys with me so far? Hello? You with me so far? Okay. Right, let's practice a little bit here. Plus 17. Okay, find the vertex. I give you 5x squared minus 20x plus 17. Okay, first of all, what do we call this thing? What's this thing called? Very good. This is called a quadratic. And why is it called a quadratic again? Just to make sure we all know. Because the degree is what? 2. And what shape, when I graph the quadratic, does it make? What's the name of the shape called? The parabola. See, there's the difference, right? So the name of the shape is the parabola. Okay, good. What's the value of a in this particular case? 5. Very good. What's the value of b in this particular case? Negative 20. What's the value of c in this particular case? 17, right? Now, of those 3 pieces of information, what are the 2 that we need to find the vertex? We need a and b. Good. So remember, our vertex has to be an x and a y coordinate. So to find the x part, what do? We take negative b over 2a. Good. So I'm going to take negative 20 all over 2 times a, which is 5. And we're going to figure this out right now. Yes, very good. 20 divided by 10 is how much? 2. Very good. So the x-coordinate of the vertex here, I'll put this over here, vertex, is going to be located at 2 comma something. All right? 2 comma something. And if we look back at our notes here, how do we get the y for this one? What do I do? It says to plug in. Does anybody have any idea what it means to plug in? Yeah, what do you think, Cody?
So you plug in the x-coordinate 2 to the quadratic.
Dude, you got it. It's absolutely right. You plug the 2 right there, plug the 2 right there, and we're going to get the y-coordinate. So y has to be 5 times, we're going to go 2 squared, minus 20 times 2, and then plus 17. Okay. So we'll have the calculator for this one. We'll go 5 times 2 squared minus 20 times 2 plus 17. Did I do it right? Let's see. Yep, there you guys. What you guys got? What's it come up with? Negative 3. Good. So we just figured out together this has to be a negative 3. So once I have that answer, I can plug that in over here to get my vertex at 2 comma negative 3. All right, what do you think? Easy, medium, or hard? Easy? Okay, let's double check and make sure that we did this right. So I'm going to go to a new spot. What was the equation we just had? 5x squared, yeah? Minus 20x, yep. Okay, plus 17. Okay, is this parabola going to open up, or is this parabola going to open down? And how do you know? What do you think? Why do you guys say down? Why do you say down? Because what's negative? B is negative, so you think it's going to open down? Okay. He says that it has to do with A, since that's the highest degree. And A is, in this case, what? Positive or negative? Positive. So do you guys think up or down? What do you think? I don't know. Let's just graph it and see. Oh, man, which way is it opening? Up. So Tyler is 100% right. It's all about the A value right there. What's the value of A in this case? 5. If A is positive, then your parabola opens up. What if A is negative? Then what? Opens down. Okay, but that's not what we were checking out for this point. We were trying to figure out where the vertex is. And what did we get for an answer? What did we get for an answer? Back over here. What was our answer for our vertex? 2 to negative 3. So look back over here. Is the vertex located at the point 2 comma negative 3? Yes, there it is right there. There's the point 2 comma negative 3. What do you think? Easy, medium, or hard? Medium. Okay. Yes, sir. You're 3. Also, check it out. The axis of symmetry would have to go right there, huh? It has to go right through the vertex. Okay, last one here. We're going to find the vertex. It says y equals negative x squared plus 4x minus 1. Okay, give me some information. What's the value of a? Negative 1. Very good. What's the value of b? Negative 4 or positive 4? Positive 4. Good. What's the value of c? Negative 1. Okay, great. The vertex is located at what point? It's going to be an x and a y. How do I find the x? What do I do? Negative b over 2a. We're going to evaluate negative b over 2a. That's going to be negative 4 over 2 times, what's a again? Negative 1. Awesome. So that is a negative 4 divided by a negative 2. How much is that? That equals a positive 2. So far our vertex is located at the point 2 comma something. 2 comma something. We have to figure out what the other part is. Yes, how do I get this y value? What do I do? I plug in. Very good. So we're going to do negative 2 squared plus 4 times 2 minus 1. What do you need?
You did give that pass to Sam, right?
Yeah.
Because his dad's reading me off.
Yeah. I gave it to him. Yeah, you got it. All right, so here we go. We're going to plug this in and we're going to go. We're going to do negative 2 squared plus 4 times 2 minus 1. So this is going to be negative 2 squared plus 8 minus 1. Okay, now in this particular case, when we have a negative 2 squared, what's it going to be? Is there a difference here between this thing? Is there a difference between negative 2 squared and negative 2 squared? Is there a difference there? Yes or no? Difference, yes or no? There is a difference. What is the difference between those two things? The parentheses, yes, very good. This actually means negative 2 times a negative 2. This actually means the negative of 4. You guys with me on that? And where'd the 4 come from? Where'd the 4 come from? 2 squared. Yeah, very good. So this is going to be negative 4 plus 7. How much is that? Anybody? 3. Yeah, very good. Negative 4 plus 7 is 3. So our vertex is located at the point 2 comma 3. And let's graph that just to be sure. Someone tell me the equation again. What was it?
Negative x squared.
Whoops, I don't want this. I want this. Negative x squared
Plus 4x.
plus 4x, yep.
Minus 1.
Minus 1. Oh, and then it was y equals, right? All right, sweet. So is this going to open up or is it going to open down? How do you know it's going to open down? Because it's negative, very good. And we'll graph it and see. Hey, check it out. It totally opens down. That's awesome. And where's the vertex located? It's located at 2, 3. Do you guys agree? That point right there is called 2 over 2 up 3. Yeah, located at 2,